In this problem, we have a piecewise function where when x is less than or equal to 5, we're graphing a radical function, and when x is greater than 5, we're graphing a linear equation. So these, I've shaded the graph where each part will lie. For that radical function, we have a vertical stretch by a factor of 3 because there's a 3 on the outside, so our y values are tripling. We have a plus 4 on the inside of the radical, which is going to be a shift to the left 4, and we have a minus 3 on the outside, which is going to be a shift down 3. So if we start by graphing the parent function for a radical, we have the point 0, 0, 1, 1, 4, 2, and even though I'm going into the red and I will eventually erase this point, I'm going to plot the point 9, 3, just to see after we move it around if we needed that point. So that's kind of what the parent function looks like. And then now I'm going to apply my vertical stretch. So my y values are tripling. It's going to be 3 times as tall. So the point 0, 0 is going to stay in the same place. The point 1, 1, if I triple the y coordinate, it's going to be over 1 up 3. The point 4, 2 is going to be over 4 up 6. Thanks, Henry. Then we go for our next point, instead of over 9 up 3, we triple that y coordinate and go over 9 up 9. And that would be the vertical stretch applied. And now we want to shift that graph. We could shift each point to the left 4 and down 3. So I'm going to take, for my final graph for this part, starting at the origin, left 4 and down 3. And then my next point was over 1 up 3 from that origin point, which has moved. My next point was over 4 up 6, which would land right here. And my next point would be over 9 from this starting place, and putting me at an x coordinate of 5, and then up 9 from there. So I'm at negative 3. I want to go up to 6. And that would be our final graph. And that actually landed on the borderline. And on that borderline, I do need to think about whether or not it should be an open or closed dot. And I do want it to be a closed dot because it was less than or equal to 5. It does have the line underneath on the inequality. And I'll try to clean this up a little bit. Erase my messy points. Okay, so there's the black graph is the part I'm ending with for that first part, and then we need to graph that line negative 2/5 x plus 8. And what I like to do for this is start on the y-axis and graph it like I would normally graph a line, and then just erase the part that I don't want. So I'll do this one in red, I guess. So if I have a y-intercept of 8, and my slope is negative 2/5, I'm going to go down to right 5, and that actually lands with an open circle on my borderline. It's an open circle because of that inequality not having a line underneath. But since the dot is already filled in there, you can just keep it a closed dot. So we don't need to indicate that that is open because they landed in the same place. And then if I go down 2 over 5 again, I get another point over here. And I don't want to keep my original point on the y-axis because it's not in the part where x is greater than 5. I only want to keep the part on the right side of the graph. So I need to erase my original point on the y-axis. So my final graph is the black part and the red part. And so I could erase all my other stuff just so we know which part we need to keep. And it looks like that. Okay, and now to answer the questions for the domain, my lowest possible x value is -4, and I'm going to use a bracket because we do hit -4. And this graph is continuous for the rest of the x values. So since those 2 points did land in the same place, I have all the x values getting greater than -4. So it's -4 to infinity. For the range, my lowest y value is -3. And so it's going to be bracket -3. And then my very highest y value that I reach on this graph is 6. And so it's -3 to 6 with a bracket. Is this function continuous over the domain? It is continuous because it never breaks apart. If you put your pen and you follow this graph, you would never have to lift it up. So it is continuous over its domain. Is there a local max or a local min? The local max would be the very highest point, where it increases and then decreases, and that would be the local max at x equals 5. And the local maximum value is the y value at that point, which is 6. The local min, there's no local min because it never decreases and then increases again. So we don't have a local min. An endpoint doesn't count as a local min. Intervals where it increases, decreases, constant, it is increasing from -4, x equals -4, to that high point at 5. And we always use parentheses for increasing and decreasing. And then it decreases from x equals 5 to infinity. And it's never constant.